Tinnitus is the perception of sound when no external source is present. It often manifests as a ringing in the ears, but can also sound like buzzing, hissing, roaring, or even music. Affecting millions worldwide, tinnitus can be deeply unsettling. It can disrupt sleep, concentration, and overall quality of life. For a long time, tinnitus was considered a purely subjective experience, a phantom noise with no clear physiological basis. However, recent research suggests that tinnitus may stem from a very real and measurable source: damage to the auditory nerve. This damage, often invisible to standard hearing tests, could be the root cause of the phantom noises that plague so many. This new understanding challenges previous assumptions about tinnitus and offers hope for more targeted and effective treatments in the future. A groundbreaking study published in the journal Current Biology offers compelling evidence linking tinnitus to a specific type of nerve damage. This damage affects the auditory nerve, which carries signals from the inner ear to the brain. Interestingly, the damage is often not detectable by standard hearing tests, also known as audiograms. This explains why many individuals with tinnitus have normal audiograms. The study's findings suggest that tinnitus may be a result of damage to a subset of nerve fibers responsible for transmitting information about louder sounds. Even if the overall hearing sensitivity remains normal, the loss of these specific fibers could lead to an imbalance in auditory processing, ultimately manifesting as tinnitus. To uncover this hidden nerve damage, the researchers employed a technique called electrocochleography. This method measures the electrical activity of the auditory nerve and brainstem in response to sound. Participants in the study, both with and without tinnitus, listened to a series of clicking sounds while their brain activity was monitored. The study included 201 individuals without tinnitus, 64 with a history of tinnitus, and 29 with chronic tinnitus. Despite all participants having passed standard hearing tests, the results revealed significant differences in the electrical responses between those with and without tinnitus. The researchers observed a consistent pattern of reduced activity in specific auditory nerve fibers among those with tinnitus, indicating damage to these fibers. This phenomenon, where individuals experience hearing difficulties despite normal audiograms, is known as hidden hearing loss. The study's findings suggest that hidden hearing loss, specifically damage to the auditory nerve fibers responsible for processing louder sounds, could be a major contributor to tinnitus. This discovery has significant implications for the development of future tinnitus treatments. By understanding the underlying mechanism of tinnitus, researchers can now focus on developing therapies aimed at repairing or regenerating these damaged nerve fibers. One promising avenue involves the use of neurotrophins, naturally occurring proteins that promote the growth and survival of nerve cells. While still in the early stages of research, the possibility of using neurotrophins to restore damaged auditory nerve fibers offers a glimmer of hope for millions seeking relief from the burden of tinnitus.